Welcome back. What we're going to be doing today is a little bit more interesting than what we've been doing before in the area of quadratic equations and simultaneous equation. Now, I want you to note something that simultaneous equation has to do with a linear equation, a simultaneous linear equation. And I'm going to be showing that to you in a brief moment from now. So what we're going to be doing is has to do with simultaneous linear and quadratic equations. If you have done WAHEC or you have done further maths in my WAHEC mathematics or WAHEC further maths, these are kind of questions comes out, and if you have been able to solve this, you can deal with any form of equations that can arise. That can come out in your WAHEC or UTME or post-JAM or UT or even JAM questions or UTME questions. So take for instance, you have this kind of equation, x plus y is equals to 5, and you have x squared plus y squared is equals to 13. This is equation 1, equation 2. Recall that this looks like a simultaneous equation, and we need to solve for x and y. X and y. Number one, what I want you to note is that this kind of equation, the second equation is the circle. You realize that you'll be able to draw out a round circle with the second equation, while the first equation is a line that cuts through the circle. Let me draw that again. A circle and a line that cuts through the circle. And the value of x that they are x and y they're asking you for is this point in which there is an intersection between the circle and the line. The line is the simultaneous linear equation x plus y, which is equals to 5, while the circle is the x raised to the power squared, x raised to the power 2 plus y raised to the power 2 is equals to 13. Now they are now telling you solve for x and y. This is very simple. What you need to do first is to make the linear equation, you make a particular variable subject of the formula by using our substitution method that we have studied in the previous lessons. Take for instance, x is equals to 5 minus y. That means I make x the subject of formula and then substitute it into equation 2. Substituting that into equation 2 will give you 5 minus y raised to the power 2 plus y squared is equals to 13. What is going to end up giving you is a quadratic equation of power raised to 2. And then you can now find the roots of the y. Now, let's complete this particular example. This is going to give you 25 minus 5y minus 5y plus y square is equals to 13. And this is invariably is going to give you 25 minus 10y minus plus 2y squared is equals to 13. collect 9 times, you're going to have, let me rewrite the equation. You're going to have 2y squared minus 10y. When 13 cross the border, it turns out to be minus. And so that we are going to be having plus 12 is equals to 0. Divide through by 2. You're going to be having y squared minus 5y plus 6. Can you see this is a lot easier? Now you can easily factorize. You don't have to use um, completing the square almighty formula in this situation, because you can easily factorize it. To factorize this, you have y squared minus 6y plus y plus 6 is equals to 0. Now, if you look at what was just being written here, we'll realize that this cannot work. Cannot be factorized to give us this value, because we are looking for what will add together that will give us minus 5, and we'll multiply together that will give us 6. Add together that will give us minus 5, multiply together that will give us 6. So what we need to do is that means we need to delete this. That means if we try minus 2y minus 3y plus 6, I think this can give us a value we're looking for. Now, if you now look at this, we will now collect like times. We say y into y minus 2. If I multiply it, it's going to give us this value back. And minus 3y minus 2. Can you see we have, if you collect like time, this is equals to this, and this is another value that attacks to this. That means we can have y minus 3 and y minus 2 is equals to 0. Knowing fully that we have our y to be minus 2 bracket y minus 3, that means the value of y is going to be 2 or 3. Now, substituting this value into equation 1, which is x plus y is equals to 5, we're going to be having x to be when y is equals to 2, x is going to be 3. When y is equals to 3, x is going to be 2. So we can now say that the coefficient of this equation, of the equation we wrote initially, is going to be 2 by 3 and 3 by 2. Three by 2, 2 by 3. And this is the equation. This is the solution to the equation. Another equation that we can have, which is a little bit less easy, is when we have equations like 3x plus 2y is equal to 10, and x squared minus xy plus y squared is equal to 21. We still have to use the power of substitution in this. When we use the power substitution in this, it will help us to be able to resolve the challenges with this question. So thank you. In our next lesson, we're going to be digging deeper into how we can solve questions that has simultaneous equation and polynomials. It takes the same concept with this. I want to believe that with this you'll be able to solve your UTME and your UTME, post UTME, and even WIHEC questions easily. Thank you.